All right, number two, we have the same directions, but it looks a little bit different. Same basic idea, though. We need to find the derivative of this and figure out if it ever changes from positive to negative or negative to positive. If it doesn't change, then it's going to be a monotone function. But taking the derivative of this, we have to refer back to the fundamental theorem of calculus, or the second fundamental theorem of calculus. If we have a definite integral from a constant to x, we can do the derivative pretty easily. We can rearrange these and put the 3 on the bottom, x on top, and realize that that's going to be the opposite of this integral. And sorry, this is a typo. This should say cosine of t and dt. So we have square root of 3 plus cosine of t dt. If we want to take the derivative of that now, second fundamental theorem of calculus basically tells us that in this case, we can actually just substitute x in for t. That's what's going to happen. If we went through the whole process, we could figure that out, but it's a nice shortcut that saves us some work. So we end up with negative square root of 3 plus cosine of t. And just like before, we need to figure out when that's 0 so that we can figure out if it changes at all. So we want to know when is this equal to 0. We can square both sides. We get 0 equals 3 plus cosine of t. So cosine of t would have to be negative 3. Problem is that can't happen. We can't have a cosine that is smaller than negative 1 or bigger than positive 1. Doesn't work. If you tried to do this in your calculator and did inverse cosine of negative 3, you're going to get an error. Cosine has to be between negative 1 and 1. So this is not going to give us any answers. That tells us the derivative is never 0. So if it's never 0 or never undefined, it can't change. So for this one, if we look at it, if we put anything into this derivative, as long as we get a value under the square root that's positive, um, then we're going to end up with a negative answer. So our derivative is always going to be negative. So our derivative is always less than 0. No matter what we put in for t, as long as it gives us something out, it's going to be negative. So it's always decreasing. So our original function f is always decreasing. So it's not changing at all, which means it's going to be a monotone function.